Welcome to GC Connect. Yesterday, um, we are discussing about different tests on cement. In the different tests on cement, um, we covered the finest test. So, in the finest test, we have two different methods are there. The first one is sieve test, and the second one is standard permeability test. So normally in this standard permeability test, we'll use the fixed quantity of air to flow on the uniform thickness of the cement bed. So the principle of the air permeability method is uh, in observing the time taken for a fixed quantity of airflow through a compacted cement bed of specified dimensions with a specified porosity. So one is it has a fixed dimensions. What I said earlier is that it is the fixed dimensions with a fixed thickness with a fixed porosity. So that much quantity of cement we have to take with a fixed porosity. Then what will be the procedure? Procedure is cement required to make a cement bed of a porosity of 0.475 is calculated. For the porosity of 0.475, we have to um, uh, calculate how much quantity of cement is required. That much we have to take it. Then pass the air slowly at a constant velocity. Then adjust the rate of airflow until the flow meter shows the difference of level of 30 to 50 centimeters. Maybe in that instrument we have one side the pressure gauge, it will be there, and one more the manometer, it will be there. In the manometer it should show 30 to 50 centimeter level. So then repeat the observation till the consistency head of that ratio it will be received, that is h1 by h2. Maybe I'll show you what is h1 and what is h2 in the manometers, but make sure that until the flow meter shows the difference of level of 30 to 50 centimeters. So here this is one instrument. You can see that on the right side you can see one pressure gauge is there. On the left hand side we can see the manometers level. That manometer level itself is 30 to 50 centimeter difference. So then standard consistency test. So this standard consistency test is used for the cement, and we'll prepare the cement paste here, and we require one plunger, and with that plunger will allow that plunger to penetrate with the help of 30 to 35 mm from the top of the mold. So then the use is, it is used to find out the percentage of water required to produce the cement paste of standard consistency. Means how much quantity of water is required for this standard consistency, that much it's the main use of that. So means sometimes it has the application of to find out the water cement ratio also. So it has based on this itself we'll find out the water, how much water cement ratio is required with to make a standard consistency or to get the standard consistency. Normally sometimes we can call this as a normal consistency also. For the first trial what you can do is that take about 500 grams of cement and mix it well with the water uh, for about 3 to 5 minutes. Then what you can do is that you can mix it well so that um, whatever the air inside in the cement paste is there, let it go faster. Then with the help of the standard plunger with a 10 mm diameter, 50 mm long is attached, brought down to touch the surface of that paste and quickly released. See whatever that paste is there, you fill it in that well and allow it to penetrate. Then note down the readings according to depth of penetration of the plunger. Then conduct the trials continuously by taking the difference of water cement ratio till the plunger penetrates for a depth of 33 to 35 meter from the top. That is not meters, that is from the top. Then see the consistency there. Once you release it, see that whether the consistency you are getting with that after releasing that plunger. So normally we will conduct this experiment at 27 plus or minus 2 degrees centigrade and with a humidity of 90%. This is very important because when you are conducting this test in some of the cold countries, cold countries means 400 degrees days centigrade, sometimes 0 degrees centigrade, sometimes minus 2 degrees and minus 3 degrees, and this consistency you won't get because water to cement ratio when you mix it, normally it depends on the temperature. If the cold temperature is there, normally it will start flowing. Once it start flowing, so you won't get that much standard consistency. That is why whenever you are doing or conducting this test, make sure that the temperature and the humidity should be constantly maintained at least for 10 minutes till the finish of the test. So normally when you are conducting this test, normally they will provide with the air conditioned type of rooms. Hmm. So you follow this suitable conditions when you are conducting this test. So then a settling time test. So we have two. One is of initial settling time and final settling time. So the as for the IS code, so what it will say is that initial settling time should be 30 minutes and final settling time should be 10 hours. So with that values only you should get it. So then what is this initial settling time is? It is the time lapsed between the moment that the water is added to the cement to the time that the paste starts losing its plasticity. So we have different limits are there. A liquid limit, plastic limit, and shrinkage limits are there. You know that what is the plastic limit, what is the liquid limit, what is the shrinkage limit in your GT lab. Go through that. So it is the time from when the water is added and when the paste starts losing its, that is a starting point of losing its plasticity. So normally a minimum 30 meter minutes has maintained for mixing and handling operations, and it should not be less than 30 minutes. Make sure that the time is 30 minutes. It should not be less than 30 minutes. Then final settling time, the time lapsed between the moment the water is added to the cement and the time when the paste has completely lost plasticity, means it is complete. Previous it was lost, it is a starting point of losing its plasticity. This one is completely losing its plasticity and has attained sufficient of fineness, firmness to resist certain defined pressure. Okay, so this is almost time will be should not exceed 10 hours, and there it is less than. Very important thing is that is it should not be less than 30 minutes and it should not be and should not exceed 10 hours. So if you are getting in these two means, it has a good cement, mm, it has a good property of cement. So it should not exceed 10 hours so that it is avoided from the least vulnerable to damage from external activities. Procedure. So weekend apparatus is used to finding the settling time. Take 500 grams of cement and add about um, 0.85 uh, paste of paste, and the paste should be filled with 3 to 5 minutes. Within 3 to 5 minutes you have to fill it, and initial final settling time is noted. So make sure that that is less than 30 minutes and it is should not be more than 10 hours. That is final uh, uh, settling time. So take sand and cement of 1:3 ratio of the cement and sand. Mix them for 1 minute, then add the water quantity, that is about 3%. Mix three ingredients thoroughly until the mixture of uniform color. The time of mixing should not be less than 10 minutes and not more than 4 minutes. This is very important. 3 to 4 minutes time should be provided. Then the mortar is filled into cube mold of 7.6 centimeter height. Then compact the mortar. You have to compact it. Then keep the compacted cube in the mold at a temperature of 27 to plus or minus 2 degrees centigrade and at least 90% of relative humidity, that is humidity, for 24 hours. And after 24 hours, cubes are removed, immersed in a clean fresh water taken for testing. Then soundness test. It is very important that the cement after setting shall not undergo any appreciable change in the volume. It should not go any change in the volume once that settling test is conducted. This test is ensure that the cement does not show any subsequent expansions. The unsoundness of the cement is due to the presence of excess of lime combined with the acetic oxide at the kiln. Normally, when you are preparing the cement, normally we'll use the kiln process. In that kiln, sometimes if the lime, if you are going to add extra, and some of the oxides, acidic oxides, if you add it, it will create unsoundness. This should not happen. So that is why when you are adding the lime, sufficient means uniform mixture of lime should be added. Of course, sometimes this unsoundness is due to the proportion of magnesium as well as the calcium sulfate. Sometimes if you add extra magnesium sulfate as well as the calcium sulfate, so this unsoundness will happen. Therefore, magnesium content of cement is limited to 6%. So not more than 6% should be added as a magnesium sulfate. This is the apparatus, we'll use it for this soundness test. Maybe I'll supply some of the videos, maybe you can go through that. Maybe in the next class we'll discuss some more tests on cement and how we are going to conduct it. Thank you.